Here's a linear regression question. So I'm given this data, age and cups of coffee. So what we want to find a linear regression equation for age in terms of cup of coffee per day. Okay, so we need to be very careful because here we're looking for age in terms of cup of coffee. So age here actually is my y variable, and cups of coffee here is my x variable. So that means this is my x and this is my y. Okay, so just be very, very careful with that. Okay, so now we want to find the linear regression equation, so let's just use our calculator. So let me go ahead and clear this. So I'm going to press stat first. I'm going to go to edit. And the first thing that I enter is going to be my x thing. And my x variable in this case is cups of coffee. So I'm going to put in 0, then 3, then I'm going to put 1, and then I'm going to put 2. Okay, so that's my x variable, the number of cups of coffee. My y variable is going to be my age. Okay, so I'm going to have 18, 25, 21, and 47. Okay, so we need to be very careful with what we're going to enter. Whatever we enter first is going to be my x variable. Whatever we enter next is going to be my y variable. Okay, so now after I enter my data, I'm going to press stat one more time, go to calculate, and then go down to number 4, which is linear regression. So remember, the steps are the same for the TI-36. Okay, so just follow along with those also, and hopefully you get this. So I got this. Let me go ahead and maximize this a little bit. So remember that we have y is equal to b plus ax. Our b value, y hat is equal to b. B in this case is equal to 20.7 plus 4.7x. All right. All right. So that's my linear regression equation. That's what we have. Okay. That's what we got. So assuming that this is linear, it's not the most interesting question, age with cups of coffee, but whatever. Okay, so now what we want to do, we want to interpret the slope and the y-intercept. So let's first start with the y-intercept. And if you remember, the y-intercept, basically what it told you was that when x is 0, your y value would be whatever the b is. So in this case, x is 0, so when x in this case is cups of coffee, when and then cups of coffee is 0, so when you drink 0 cups of coffee, okay, so when you have 0 cups of coffee, your predicted age will be what? So your predicted age will be 20.7. That's basically what that means. So if you drink 0 cups of coffee, that means that your predicted age is 20.7 years old. Okay. The slope, what does the slope mean? So remember, the slope tells you that when you increase your x value by 1, so when I increase my cups of coffee by 1, how much does my y change? My y changes by whatever a is. So when my x, in this case my x is cups of coffee, when my cups of coffee increase by 1, so if I decide to drink 1 more cup of coffee, my predicted age, okay, which is our y, my predicted age will be, will increase by 4.7 years. Okay, because that's whatever my y is. So my age actually is going to increase by this 4.7, so whatever this a value is. Okay, if you want to go ahead and go by what I was writing on the board on this past week, then just go ahead and write that down. Okay, I will accept both answers as long as it makes somewhat of sense. Okay, so cups of coffee and age. Okay. So in this case, what I want to do, what is the coefficient of determination and interpret it. So let's go back to the calculator. And if you remember, the coefficient of determination is basically just our R squared value. So we're looking for what is R squared. So if I go back to the calculator, R squared is 0.2129. So R squared in this case, let me go back. This is going to be equal to 0.2129. 0.2129, which is basically 21.3%. Okay, so what is that? What does this mean? So remember that this is just tells you the amount of variation. Okay, so you can say 21.3% of the variation in Y. Well, what is Y? Y is ages. Variation in ages can be explained by X. So X in this case is cups of coffee. Can be explained by cups of coffee, or number of cups of coffee. So 21.3% of the variation in ages can be explained by cups of coffee. Okay, that's basically what the coefficient of determination basically does. So I'm able to explain 21.3% of the variation in ages. So of all the variations of ages, I can explain 21% by cups of coffee. Okay. All right. So now part D says, do you think that age and cups of coffee per day are related? Explain. Well, based on our data, if we look at, first of all, did it go away? Okay, if we look at our correlation is about 0.46, which is pretty weak. Okay, it's a weak positive correlation. And then our R squared value also is 21.3%. So based on the data that we have, we can't really say much, right? There's not a strong correlation, and our coefficient of determination is pretty low. So all we can say is based on our data that we collected, there is not a strong correlation. Okay, so can we say that they're related? Well, we don't know because we don't have a big enough sample. If you can tell, we only have four samples, and our correlation is not strong. Our coefficient of determination is pretty also low too. So, I mean, we can't really say anything based on this. We would have to gather more samples. We would also have to look at other variables too, because I think it's kind of dumb just to look at age and cups of coffee by itself. So, so these are really good ways, and a really good example on how to use linear regression and how to interpret. This is basically what I'm looking for the exam.